Hey guys, welcome to day 2 of my free networking course. You're about to embark on an exciting journey into the world of networking with network coders. Thank you for choosing to start this journey with me. I trust that you'll find this course both enjoyable and informative. By the end of today's lesson, you'll have a solid understanding of routers and network geography, the role it plays in the network, and configuring network devices in the network. So as always, we'll be using Cisco Packet Tracer to visualize some of these concepts. So let's get started. Okay, so let's take a recap at what we learned in the last episode. So, what we remember now about switches is that it is a network device that ensures that data is sent to the correct device. It has a kern table where it records all the MAC addresses of the different devices that are connected in that specific network. And a MAC address is actually a numeric attribute that identifies the network device that is in that network. So a switch is also a layer 2 device of the OSI model. So you don't need to know what an OSI model right now, but what you need to know in the exam is that a switch is a layer 2 device and it is used to send data to the correct devices that are within the same network. So in today's episode, we are going to be looking at network geography and routers. And the reason why I'm going to be starting with network geography is because of the depth it has and how networks can be scalable. So we're also going to be looking at how routers are used in these big networks. So please stay along and like, subscribe. Please turn on those notification buttons so you don't miss an episode. Let's get back into the video. Right. When we're looking at the network geography, we are going to be starting off with the personal area network, moving on to the local area network, campus area network, metropolitan network, and the wide area network. So when we look at the personal area network, it is the smallest type of network. It can be wired or wireless. And then an example of that would be connecting your cell phone to a car radio using Bluetooth. And I'm sure most people use that to connect to the Bluetooth when you're listening to music or answering your cell phone. And then the second example would be using a USB drive to connect to your laptop, either to sending files, sending music, or just sharing different types of data. And then when we look at the local area network, so it connects devices within a limited distance. Each segment is limited to a short distance depending on the cabling. It usually consists of Ethernet or Wi-Fi networks, and using those two standards, which we are going to be looking at a later stage. But then now the examples are internal networks in a business and the residential wireless network. So if I could give you a practical example of a internal network that's located in a business, you'll be looking at a setup of a normal office. So you'll get people that are using PCs or desktops. So those desktops will be connected with a LAN cable to the switch, and that switch now is catering for sharing the data between the devices that are connected in that network, or maybe using the Wi-Fi network and using multiple wireless access point throughout the building to share the data from the different devices. And then we're looking at the campus area network. So it connects building-centric lands across a university, industrial park, or business park. It can cover several meters and dozens of buildings. So an example would be university campus with multiple buildings or a business park. So when I think about this type of network, I think about my own university that I studied at. So we used to go to labs, we used to go to administration centers, we used to go to different residences. So within that campus, you are able to access the network using multiple media, which is your LAN or your Wi-Fi network. But in all that, it encompasses a campus area network where there's multiple LAN in per building, but in all that it connects throughout the campus itself. So it's building centric, and it covers a limited distance across the different buildings that are within that campus. And then when we look at the metropolitan area network, so it connects scattered locations across a city or country. It's larger than a campus area network, but smaller than a wide area network. So examples would be university campus spread across a country, or police department. So either two of them, when it comes to police departments or universities, we know that they are widely scattered across a country. So for example, let's say you're looking at a university like Nelson Mandela University. It has campuses across the country. It has many of them, but the way communication is carried out through the different campuses is that we can either use a virtual private network or multiple VLANs across the the network itself. So it's quite versatile when you want to access the network, but you have to be within the Nelson Mandela University network, which is that virtual private network that is used across there. So it's quite big, but not as big as a wide area network. But we'll be covering that in this video as well, which is the next one. So a wide area network connects geographically dispersed internal networks, can cover several meters and dozens of buildings. So it consists of lease lines or virtual private networks tunneled over the internet. So it covers distances across the country or around the world. And an example of that is the largest wide area network, which is the internet, which everyone subscribes to, and connecting two private corporate networks. So wide area network is the largest network that is known to man, and it covers a huge space because it's actually global. And a lot of people that are connected to the internet have the ability to access different websites. They can talk to people across different countries. So that's the power of the wide area network. And yeah, I hope you guys learned a lot when it comes to network geography. So what we spoke about in this section of the lesson is a PAN, which is around a person, a LAN, which could be in a room or a building, a campus area network. It's limited between a campus or business park, a metropolitan area network comprising of a city or country, and then the wide area network, which consists of a range between a country or worldwide. So thank you for holding up and listening to this section. So now we're going to be moving on to routers and how routers are used in the different scales of the network geography and how they interact with different networks. Okay, great guys. So now we're going to be looking at routers, but there's one question we need to ask first. So how does network geography tie into routers? So basically routers are devices that manage the flow of data across different geographies. So they are the key to connecting various networks, directing data from one location to another, ensuring it reaches the correct destination efficiently. So when you're actually thinking about routers, is that you need to think of them as navigators of traffic controllers of the network. So just as you use your GPS to find the best route to the destination, so routers use the same concept. So they have routing tables and algorithms to find the best path for the data to travel across a network. So whether it's within a LAN, across a WAN, or through the internet. So in today's session, we'll also be using Cisco Packet Tracer to illustrate that, so you can get the best picture of how routers actually work. So I'm going to be actually building a network which is a LAN network, but it will be comprising of two departments. Let's say an HR department or an IT department. So they'll be connected with a router and then sending data from one department to another. So let's get into Cisco Packet Tracer and illustrate that concept. Hey guys, so in this section we'll actually be looking at Cisco Packet Tracer and making sure that we reach the goals of this session, where we look at routers and how they interact between two different LAN networks. So we'll be having an HR department and a IT department and adding a few devices so that we can simulate packets being sent from one department to another department. So let's quickly get onto Cisco Packet Tracer and make sure that you also have your PCs open and follow along. So we'll be having PCs from the HR department and PCs for the IT department. So connecting these PCs, will be actually having a switch and then the star of the show, which is the router. So in order for these devices to connect with each other, we need to actually add some cabling from the PC to the switch. So this is fast Ethernet cabling, and then we do that on the PC to the switch, which is in the IT department. So just for reference, I want to actually label these so that you guys can see which one is which. HR department and the IT department. Okay, great. Okay, now that looks more like it. So let me move these over here. Okay, great. So now to connect the switch to the router, I'm going to be using Giga Ethernet cabling from switch to router, and then I'm going to also use Giga Ethernet from this end of the LAN network to the router. So if you notice now that the cabling from the router to the switch has red triangles, meaning that there's no connection between these two LAN networks. So what I'm going to do first is actually configure the router so that it can be able to communicate with the switches and route our packets that we need for this lesson. So I'm going to jump on into the CLI, and it's asking us, would you like to enter the initial configuration dialog? We are going to say no, and then we are going to say enable, and then configure terminal, and then we're going to go straight to the interface which is the Giga Ethernet, which is that port 0/0, and then the IP address, which is the exiting IP address of the LAN network of the HR department, so which is 192.168.1.1, and then we are going to put in our subnet mask 255.255.255.0. Okay, great. And then we are going to say no shutdown. Okay, great. So our Giga Ethernet change state to up. Lovely. Now we are going to say exit that interface, and then we are going to go straight into interface for the IT department side, which is G0/1. Enter, and then the IP address, which is 192.168.2 .1. So the reason why it's saying .2.1, oh, I need to actually charge my laptop before it shuts down, so I'm going to quickly charge my laptop. Okay, great. So before my laptop switched off, so we were actually talking about the reason why we are having a .1.1 and a .2.1 IP addresses. So basically either of them belong to a network. So the .1 belongs to the HR department and the .2 belongs to the IT department. They need to be different so that the router knows that these two networks are different from each other. It's not coming from the same network, so that it can be able to actually route those packets from one department to another. So I'm going to be carrying on with configuring the interface for the IT department. So the subnet mask is 255.255.255.0. No shutdown. Okay, great. So now we are done with configuring the CLI of the router. So change state to up, so which means that both interfaces are connected. So if you notice now that we have green triangles, so which means everything is up and running, and now we can start configuring the PCs. So we're going to click on the PC, go to desktop, IP configuration 192.168.1.10. Subnet mask is assigned, and then we are going to be configuring the default gateway, which is the router 192.168.1.1. so that exiting IP address belongs to the HR department. And then since this one is also in the same network, which is the HR department network, we are going to be doing the same on this side as well. So 168.1.11, and then when we configure the default gateway, it's going to be 192.168.1.1, which is the same as the same PC that we configured. And then now we are going to actually configure the IT department's devices, which is the two PCs. So we're going to do the same on this side. IP address is 192.168.2.10, and then we are going to configure the default gateway 192.168.2.1, and then we're going to do the same on this PC since it's in the same network, which is the IT department this time around. So 192.168.2.11. Subnet mask assigned 192.168.2.1. Okay, great. So now that we have configured all the devices that are in our network, now we're actually going to test our packets if they're actually going to route from one PC in one department to another PC in another department. But first, we actually want to test if the PC is going to send that packet to the router successfully. And if you look at the bottom right hand corner, we have a real-time status bar which is going to actually validate if our packets have routed successfully. So I'm going to take this packet over here and then send it to the router. So if you notice, our packet was successful. So now I'm also going to test from the IT department to the router just to make sure. We always want to make sure if the
connections in our network are configured correctly. So that one is also successful. So now we have got to brace and make sure that that packet from the HR department to the IT department is going to reach the network successfully. So now what I'm going to do is click on this PC, simulating a message sending from the HR department to an employee in the IT department. Wow, so that one was also successful. So if you look at the status bar at the bottom, it says last status successful from PC 26 from the HR department, the destination PC 28 in the IT department. So that sums it up for this section of the lesson, and I hope you guys have learned a lot, and I'm sure you guys will build your own network and add different departments so that you can actually challenge yourself in this session of the course. And I hope you understood a lot about network geography and the router and how it plays a role in terms of routing data from one network to another network. Okay guys, so well done for reaching this section of the course, and I hope you learned a lot about network geography and the routers. So what we actually picked up is that routers are essential for routing packets from one network to another. So if you've seen in this lesson, we created an HR department and an IT department. So those were two LAN networks, and we use a router to actually route packets from a PC from the HR department. So that means if an HR personnel will be sending a message to a person who's in HR who is in an IT department, will be taking that packet, routing it from the switch to the router and to that switch in the other LAN network, which is in the IT department, to the destination PC. So I hope you guys learned a lot. Make sure you do subscribe, do like this video, and also switch those notification bells so that you never miss an episode. So I'll be seeing you in the next lesson, and please make sure you also recreate your own network so that you can have a deeper understanding of how routers work in network geography. Thanks a lot, and see you on the next one.